Assalamualaikum warahmatullahi wabarakatuh. My name is FATIN FAUZI, and I would like to present my review paper on the mechanical and morphological properties of polyurethane filled with hybrid composite. Hybrid composite. Hybrid composite is material composite consists of two constituents combined together. The compound is inorganic and the other organic in nature. For example, kenaf and carbon. For polyurethane, we use polyurethane because they have characteristic of lightweight, have a good performance on harsh environment, and also have a good bonding properties between the other materials. Kenaf, we use kenaf because they have a good mechanical property. They can provide us mechanical properties such as tensile properties, compressional properties, and it is a eco-friendly polymer composite. Carbon we extract from waste tire. We use carbon because of carbon have a high stiffness, high tensile strength, and also have high temperature resistance. My objective of this review paper is that to determine and compare the findings on the mechanical and morphological properties of polyurethane filled with hybrid composite. This is the preparation of specimen by other researcher. As you can see that the formations of polyurethane is the mixture of the polyols and isocyanate and with other substances such as blowing agent, blowing catalyst, galling catalyst, and surfactant. Next on the formation of polyurethane with 30% of kenaf, polyurethane with 4% of carbon, and polyurethane with kenaf and carbon fiber. This is the testing and the characterization used by other researchers on conducting mechanical testing, such as compression test, tensile test, fractional test. And on the morphological testing, they use SEM, scanning electron microscope. Next, on the mechanical properties. First, compression properties. Compression requires the quality of the interface between the fiber and matrix and the rigidity of the resin. The stiffer matrix supports the fiber better on the side, thus delaying the fiber microbuckle and increasing the strain to failure. As based on the graph, this is graph shows that the compression strength of polyurethane composite and polyurethane hybrid composite with different densities by Streetheart et al. In 2020. As you can see that hybrid has the highest compression strength between the other materials. This proves us that hybrid can enhance the compressive properties of the materials. Next, this table is taken from Jumahat et al. In 2014. Conducted experiment on carbon and kenaf fiber on polyurethane. On the hybrid part, despite being the second highest on compression properties, this shows that hybrid can increase on the compression properties of the materials. Next, on tensile properties. Tensile properties is the ability of material to resist tearing due to tension. This graph shows that tensile strength and tensile modulus of polyurethane filled with hybrid composite of Rosell and sugar palm by Razi et al. In 2018. They have slightly decreasing of the tensile properties due when the additions of sugar palm fiber. This graph proves us that not all fiber is suitable for hybrid composite and may have a weak adhesion between the particles of the specimen. The next on the bar chart of the tensile strength and tensile modulus of carbon Kevlar hybrid composite by Hashim et al. In 2017. On CK epoxy have the highest tensile strength and tensile modulus. This may cause the additions of carbon that contribute on the good results and may have a good agglomeration between the particles. And this also can prove that carbon can increase the hybrid composite of the materials. Next, on the flexural properties. Flexural strength informs about the resistance of materials against deformation. It indicates how much force is required to break a test sample. The higher the value, the more impacting force the material is able to withstand. As you can see that this is the list of mechanical properties of materials or this Kaki et al. In 2020. On 10% of glass fiber and 5% of sisal fiber, they have the highest structural properties between the other specimen. Thus, this proves us that hybrid composite also can increase the structural properties of the polyurethane. Next, on the bending strength and the bending modulus of carbon Kevlar hybrid composite based on Hashim et al. In 2017. Carbon Kevlar epoxy have the highest bending strength and bending modulus. From this shows that the carbon also contribute in the increasing of the structural properties of a polyurethane. Next, on the morphological properties. First, hybrid composite based on Jani et al. In 2017 on surface morphology of hybrid composite with fillers and without fillers. From figure A, show that fiber surface morphology of hybrid composite without fillers. We can see that have a susceptible to severe erosion and composite fiber pools. That is related to the material behavior which have high impact, high speed energy impact, and absence of binding composite free properties. On figure B, surface morphology of hybrid composite with fillers demonstrate that no bonding strength of the weak matrix materials and fiber shooting. This can be justified since the matrix has mesh removal and severe surface damage, creating inclination of the throat wall. Next, on hybrid Knauf composite, as you can see that they have a few gaps, few fiber fractures, and few matrix cracks. This picture is from SEM of flexural fracture surface of unsaturated polyurethane and Knauf fiber by NAJMI et al. In 2018. This is because the link between the matrix and the fiber reinforcement is weakened relative to greater fiber loads. Hence, the smaller the fiber load, the greater the polymeric raising and lower the matrix and strengthening the connection. Next, on the hybrid carbon composite. This picture is SEM macrograph by Ashok et al. In 2018. On specimen C2, we have a fiber pull out, and on specimen C3, we have a voids due to fiber breakage. This may caused by the unsuitable fiber connections, and fibers may break out of the matrix. On specimen C4 and C5, we have the presence of epoxy matrix and presence of carbon fiber. It is concluded that the presence of carbon fiber is increasing the quantities and also enhance the mechanical characteristic and fails to matrix cause to fiber breaking. For my conclusion is that the characteristic of the fillers give a significant contribution to increasing the compression, tensile, and flexural properties of the hybrid composite materials. Also have a fine distribution of molecule that shows that regular smaller cell foam give greater strength and more strength. This shows that the additions of Knauf and carbon filler to form hybrid composite with polyurethane can enhance the mechanical properties and also have a good morphological properties of the materials. That's all from me. Thank you.